What does an equation have that an expression does not? Good, Jalen. Equations have equal signs. Expressions do not have equal signs, so no equal sign. Okay? Because basically what the expression is an expression is what you would be plugging into your calculator. Okay? So, well, we can start off by, let's label AC. AC can be our x. Now I have angle B. Which ratio can I use that will implement x and 7.8? Good. Sine of B. Sine of B. Because sine of B, if this is our 90-degree angle, sine is what over what? Good. Sine would be x over 7.8, but more broadly, sine is always what over what? Good. Opposite over hypotenuse. Cool. So in this case, sine of B, or sine of, we know that B is equal to 67, so I can put that in. Sine of 67 is x over 7.8. But that's an equation, right? So what I want is the expression that will help me find my final answer. So in order to find my final answer, what has to happen on both sides? We multiply both sides by 7.8. So in the end, I get x equals 7.8 times the sine of 67. Now this is an equation. This is an equation. However, since I've isolated the x is all alone, I know that this portion of my equation can be used to find x. So that's my expression, 7.8 times the sine of 67. Any questions on this bell ringer? Okay. All right. So we're going to go ahead and split off into our groups. Let me send the PowerPoint again so that you guys can have it open. Give me one moment to pull it up. So right now we're on slide number 13. I skipped 12. So you're going to do 12 from 12 to the end, but we did 13 already. So 12 to the end, skipping number 13. Yeah, I'm repping today. Okay, it's loading, but as soon as I get it, I'll send it over. All right. So Perla, Emily, Janelle's, go ahead and click on the link. And just let me know when the three of you have it open, let me know. That way I can put you into your group. You're good? Emily, you good? Yep, all right. So the three of you can go ahead. Everybody else stay here. And we'll go ahead and get started on these together. So same rules as yesterday. Same rules as yesterday. So Daniel, Eric, Rios, Jalen, Samaj, I want to see participation. You guys did really well yesterday, so keep that up. Okay, and then the other thing is just make sure that you're writing your notes down. So make sure that whatever we do in class, you go ahead and you do on your sheet of paper. Yes, Janelle's, skip 13 because we just did it. We just did it, that's why. Okay, so 12 till the end. All right. So here we go. Here's number 12. Can I have Alejandro Rios start us off and read this problem, please?
Standing by the lighthouse at L point, you locate the two
Buoys.
buoys. Yeah, I never actually seen one before, so that's why I don't know.
That's
At
okay.
point J and K, you know that the point is J is 72 yards from the lighthouse and K is 75 from the lighthouse, and the point K is 21 yards at the right of the point J. Which is the following inverse trigonometric ratios can be used to find angle L?
Awesome. Thank you. Okay, so angle L is our unknown angle. This is our unknown angle. So we're going to talk about inverse functions, inverse trig functions. And the thing is, inverse functions are just the opposite of each of those functions. So inverse sine is the opposite of sine, inverse cosine is the opposite of cosine, and inverse tangent is the opposite of tangent. And what we need to do is, if we're looking for angle L, let's actually go ahead and pick one ratio to use. So Jalen, let me know, do you want to use sine, cosine, or tangent? Either one, doesn't matter.
Cosine.
Cosine? Okay.
Yeah.
So what would be cosine of L? Let's see, Eric, what would be cosine of L? Eric, are you able to answer? Not sure, because I can't hear you. So if you're, just let me know in the chat if you're able to answer me. Okay. So instead of Eric, I'll throw it right back to Jalen. What would be the cosine of L?
Sine of K.
Ooh, okay, you're right. So cosine of L is the same as the sine of K. That is 100% correct. But what I'm asking more is, what are the actual numbers that would go into the cosine of L?
Wouldn't it be like, since that's 90 and that's already gonna be, what's the name, half of 180.
Mm-hmm.
So I'm pretty sure it's probably gonna be 45 or less. I don't know.
Okay, that's true, but again, that's not what I'm asking. I'm just asking the cosine is adjacent over hypotenuse, right? So for L, what would be those numbers? Adjacent over hypotenuse.
Oh, you meant that.
That's what I meant. Yeah.
Hold on, wait, I gotta look at my notes real quick. Okay, I can't find it, so I'm just gonna take a shot in the dark. 75 over 22.
Over
No,
22.
I think I'm wrong. 72.
72. Okay.
Or it's the other way around.
It's the other way around. 72 over 75, because the longest side is the hypotenuse. Don't forget, the longest is always the hypotenuse. So that's 75 is the hypotenuse in the denominator. And then adjacent means next to. So 72 is next to L. So that's my adjacent side. Okay, so the cosine of L is 72 over 75. Well, if I want to figure out the actual measurement of L, all I need to do is look at this little equation I've set up for myself. Look at that little equation. The L, you can think of it like it's trapped inside of those parentheses. Okay, you got to get them out of there. Well, the only way to get the L out of there is to take the inverse cosine of both sides. So that's what the inverse means. Like, for example, I see Eric, you're back. That's good. So Eric, what would be the inverse of multiplication?
Division.
Division, right? What is the inverse of subtraction?
Addition.
Addition. So in this case, the inverse of cosine is just the inverse cosine. So that's what that means. It's like the opposite of doing the cosine. So when you take the inverse cosine of both sides, it cancels out the cosine. And now what am I left with on the left side? If my cosines have canceled out, what's the only thing that's left?
L.
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 Yeah. So L is alone. And on the right side, I have the inverse cosine of 72 over 75. So at the end, that's one of my answer choices. Let me move this over. That's one of my answer choices, because in order to find L, I need to take the inverse cosine of 72 over 75. So do we see that? Yes, I see it. But cosine's not the only function we can use, because we have all three side lengths. So Jalen decided to do cosine, and that was great. Now I'll have Samaj. Can you tell me a different one to use? Do you want to use sine or tangent? Sine or tangent? Doesn't matter which one. Okay, I'm going to send her a message. I just want to make sure she can hear me. Okay, Rios, let me know. Sine or tangent? Your choice.
We're answering. Oh no, we're not answering. Okay, sine.
Yeah, just let your choice. Sine. Okay. So what would be the sine of L? We already did cosine. What would be the sine?
If I'm correct, I think it has opposite.
Mhm.
I forgot like
So-
forgot the opposite denominator or numerator. So
Oh, okay. Let me clarify that. So when I say SOHCAHTOA, so we're looking at sine, so it's opposite and it's hypotenuse. And for all three of these, Rios, it's always the first letter over the second letter. So this would be opposite over hypotenuse. For cosine,
I need to remember how to spell SOHCAHTOA.
yeah, write it down right now. Write it right now.
Use the abbreviation SOHCAHTOA car.
How does that help?
SOHCAHTOA car. Tow a car.
Like towing a car. I always thought of SOHCAHTOA like let's say you're playing soccer and you go to kick the ball, but you accidentally like you hit like a pole instead or something, and
That
really hurts. And so you gotta go soak your toe
I thought it as a city.
in some ice.
I thought about saying that, but I was like,
That's kind of dumb.
yeah, it's kind of dumb.
Anyways, so what were we saying? So it's opposite over hypotenuse. So what would that be for L? Rios, back to you.
Okay, so it's opposite. Wait, okay. This is from sine out, so it's opposite 21 and 72.
Careful, which one's the longest
75.
side? Good, 75. Good. Okay. And now same as before, L is what we're looking for, but L is inside of that sine function. So I have to take the inverse sine of both sides to get it out of there. Okay. So again, on the left side, all these signs, they all cancel out with each other, and I'm left just with L. So L equals the inverse sine of 21 over 75. So that would be the first answer choice.
I have a question.
Mhm.
Is it possible you can multiply a number by a negative exponent?
Yes, it is, but that's not really what this, so don't think of this as an exponent. This is not an exponent. It's more of like a symbol. Like in math, a lot of times, that's just how we mathematically write the inverse. So if I'm trying to say, oh, it's the inverse sine, that's just how you do, that's how you say it mathematically. Does that kind of make sense? So
Yeah.
don't think of it like an exponent, because it's not really one.
I had that question for like a long time.
No, I'm glad you asked it, because it can be a little confusing. Okay. So now, last one. Now we're going to do tan. We did sine, we did cosine. Let's do tangent. Who hasn't answered this question? I think Eric hasn't done this yet. So what would be the tangent of L, Eric? (21 over 72). Very good. Opposite, 21, opposite over adjacent. Opposite over adjacent. So let me actually write all of these down. Cool. And then finally, just like everything else, we got to break that L out of there. So we're going to use the inverse tangent of both sides. Which leaves me with L all by itself. And I have the inverse tangent of 21 over 72. So that last answer choice. Okay, so inverse sine, inverse cosine, inverse tangent, those are always used in order to find the measurement of the angle itself. Because in this problem, we knew all three side lengths, but what we were missing was the actual angle. So what we're going to do now, even though the question doesn't really ask to do this, but let's just practice how to do this on our calculators, because let's actually figure out what that measurement is. So we need to do the inverse tangent of 21 over 72. So go ahead and get your calculators open. Doesn't matter. I don't care which calculator you use. Just have any calculator, because they're all going to have very similar numbers or symbols on it. How do I get to the inverse tangent button?
Second.
Good. Press that second. It can look on your calculator. It should be probably on the top left corner usually. So look for that second button. And if I'm finding the inverse tangent of, what was it? 21 over 72. What should I do first in my calculator?
I'm supposed to put the, what's the name? What is that? The fraction first, then do it?
Yeah, so do the fraction first. So 21 divided by 72. Do that first. Have your answer on there. Then you hit the inverse tangent button. And there's my answer.
Oh, 16.26.
So remember when you said, Jalen, you were like, it's probably going to be less than 42 degrees. You're right. You're totally right. Or 45 degrees. Yeah. Does anyone want me to show one more time how to do it on their calculator?
So the other one must be 73.73.
Yeah,
Wow.
because they have to add up to 90. So this was, what was it? 16.26 degrees. So it's pretty cool because like if you know the side lengths of a right triangle, you can always figure out how much each angle measures by using the inverse functions. Any questions on this whole problem?
No.
Okay, let's move right along. We did this one as the bell ringer, so let's go ahead and do this one. So the right triangle shown is missing the lengths of 2 sides. Enter the lengths of the 2 missing sides in the boxes below. Round your answer to the nearest tenth. Okay, so first it's asking us for the hypotenuse. So whenever you have a missing side, you're always going to label it with an X. And what I suggest on your notebook and your sheet of paper, draw the triangle and label it the same way that I have it, so that when you're studying, oops, I just dropped my pen, so that when you're studying, you can remember what you did. So if you have the picture in your notebook, it's going to be a lot easier. All right. Well, now here's what we always have to do. We're trying to find the value of X. And we have 2 things that we know. We know this angle 40, and we know this side length. And what you always want to think about is which ratio you want to use. So do we want to use sine? Do we want to use cosine? Or do we want to use tangent? And the way to figure it out is think, okay, if I know angle 40, this is angle 40. So what do I know in reference to angle 40? Which side is that? If I'm talking about angle 40, is the 8 centimeters the opposite side or the adjacent side?
The ADG.
That's the adjacent. So I'm probably gonna use one of these. The X, what's that? Is that the opposite or is that the hypotenuse?
I'll let someone else get this.
How about Daniel? Daniel, what is the X side called? Is that the opposite side or is that the hypotenuse? Daniel, can you hear me? I'm gonna have to text one of my in-school young ladies. So
You can automatically X out T. It has an opposite in it.
Yeah. So it's not tan, it's cosine we want to use. Because we have the adjacent angle or adjacent side, and we have the hypotenuse. So the only function that involves the adjacent and the hypotenuse is cosine. So now we set up our little equation. The cosine of 40, what would it be? Let me have Rios. Cosine of 40, what would I put into my ratio?
The cosine of 40. Okay, so 40 is right here. X over 8, I think. I don't know.
Adjacent over hypotenuse. Which one's the hypotenuse? Which one's the longest?
8 over X. Is it 8 over X?
There you go. It's 8 over X. 8 over X, because it's adjacent over hypotenuse. So there's my equation. Well, now I have to solve this equation, and I need to figure out the value of X. What would I have to do to both sides?
Divide by X. Wait,
Divide?
multiply.
Multiply. Yeah, multiply.
Yeah.
Good. We're multiplying by X because we want to get the X out of the denominator. So we multiply by x. So now I have x times the cosine of 40 equals 8. Well, if I'm trying to get x all by itself, what should I do to both sides here?
So you want x by itself. Okay.
Mhm.
So we first figure out what the cosine of 40 is, then subtract that by 8, or yeah, something like that.
You can do that, but the problem with that is that the cosine of 40 is going to be like a really long decimal. So you don't want to do that until the last step. But what you said after that, how would I get cosine of 40 to the other side? Would I add it, subtract it, multiply it, or divide it?
Subtract? I'm kind of confused.
Okay, that's okay. Let me ask somebody else. So, Eric, what operation is happening between the x and the cosine of 40?
Can you see that again? Correct.
Yeah. What operation is happening between the x and the cosine of 40? Right here. Am I doing x plus the cosine of 40, x times the cosine of 40, x divided by it? What's going on?
Times.
Yes, good. It's multiplying because that dot, don't forget that in math, a dot is multiplication. So since I'm multiplying, what is the opposite of multiplication?
Division.
Division. So that's what we got to do, okay? So we're going to divide by the cosine of 40 on both sides. Which, because this is algebra, right? It cancels out. And so I'm left with x equals 8 divided by the cosine of 40. Does that make sense, Jalen? Do you feel a little better now?
A little bit.
A little bit? Okay, I'm going to show you a trick. I want to see if this helps. I'm going to go back to where we started. Okay, so in our original equation, x was in the denominator, right? And so something that we can do, this is kind of like a little trick that you can always do, is you can switch out the number that it's equal to
Oh,
comes
I know what
down,
you're talking about.
and the x, yeah, and the x can go in its place. So see how you can kind of switch them around. And that's what I got in the end, wasn't it? After all that work, I ended up with that exact same thing. So if all that mathematic work, if all that algebra confuses you, then just remember that little trick, okay? Where you can switch the x with the cosine of 40. But now we actually have to calculate it. Now we actually have to figure out what is 8 divided by the cosine of 40. So here's where we go to our calculators, and we're going to be very careful. We're going to be very careful because we're going to have to use some parentheses. So just follow along. Get your calculators open and follow with me. We're doing 8 divided by the cosine of 40. So I'm going to do 8 divided by 8 divided by. So we're starting with that. We're taking the cosine of 40. So I don't need my second button because I'm just doing the regular cosine of 40. So I hit 40, then I hit cosine, then I hit enter. So it's 10
Oh, I get the same thing.
Good. And I'm going to do
But
it.
I did, what's your name? What did I do? I did 8 divided by cosine, no, in parentheses, cosine of 40.
Good, even better, honestly. If you put parentheses, that just guarantees that you aren't messing things up. Yeah, that's another way to, you just have to make sure you hit enter at the end. So 10.44. Anybody got something different or they want me to show it one more time? Ooh, chronic migraine information. Nice. These ads are so random. So no questions on this? 10.44. And we're rounding it to the nearest 10th. So we got
Oh, I
X.
cleared mine, so now I forgot what it is.
I got it. It was 10.44. So which number do I round to if it's to the nearest 10th?
I'm pretty sure, wait, that's ones. 4, the first 4
You
after
got
the
it.
period.
Good. So this is 10.4 centimeters. Ooh. Questions on that so far? Because we're not done. We have to do one more. Okay. Well, now I need to find the one missing side that we have left. So instead of calling it X, I'll call this one Y. And now let's reevaluate what we have, because now I have this Y right here, and I have the 8 centimeter at the bottom. So in terms of the number 40, what two sides do I have?
8 centimeters and 10.4 centimeters.
Okay, so we have 10.4, but we're kind of ignoring it for now because, well, we can use it. We can use it, but if you don't use it, we can still do it with the other two sides. So in terms of 40, do I have the opposite side, do I have the adjacent side, or do I have the hypotenuse?
Tow a car.
Toa, good. We have the opposite, which is Y, and we have the adjacent, which is 8. So that means we can use the tangent. So here we go. So we're going to set up the equation. Tangent of 40. I'll give this one to Eric. What would be the tangent of 40? And I'll remind us, tangent is opposite over adjacent.
Is anyone there?
Yeah, Eric, I can't hear you. Are you saying something? And let me just check. Daniel, can you hear me? Samaj, can you hear me? Oh, he is here.
Man, I sound tired.
Man. All right, Daniel,
Yes.
let's wake you up a little bit. What would be the tangent of 40? What would I put into my equation? Let's go, Daniel. Tangent of 40, what would it be based on my triangle? Mm-hmm.
Let me help you out. Y is on top.
Negative 1.117214930992.
No, Daniel, that's not what I'm asking. I'm asking you, based on my triangle, what is the ratio that makes the tangent of 40? Opposite over adjacent, what would that be on my triangle?
Opposite over adjacent.
Would be what?
Over it.
What would it be?
Y over 8.
Y over 8. Okay. Wake up, man. Wake up. We are working on these problems. I need you here with me.
I'd rather wake down.
No, you're waking up. You're waking up.
Wake down.
You're gonna talk back to me like that, Daniel? Okay, I didn't think so. Okay. Now, Rios, what do I have to do to both sides to get y by itself in this equation?
Wait. I think like yeah, I forgot. Oh,
Where-
y by itself. Okay. I think I have to multiply 8.
Good. Multiply by 8. Beautiful. All right. Well, now we got to use our calculators because we know that we have to do 8 times the tangent of 40. So 8 times the tangent of 40. So I go to my calculator, type in 40, find the tangent, and multiply it by 8. And we get 6.71. 6.71 to the nearest tenth, what would that be?
Yeah, 6.7.
6.7, good. Okay, so there you go. If you know one angle and one side of a right triangle, you can figure out everything else. So we just proved that, right? We got 6.7 and we got 10.4. All you need is to know one side length and you can figure out all the rest of them. Any questions on this problem? Okay. Moving on, here we go. Daniel, go ahead and read for us what's going on in this problem.
A 225-foot support wire is attached to the top of a monument at a stake on the ground 100 feet from the base of the monument as shown. Part A, what is the approximate height of the monument?
Perfect. So we're looking for the height. So I've got my x.
202 feet.
202 feet? Let's find
Yes.
out.
It can't be more than 225 because that line is slanted, so that automatically has more value.
Mm-hmm.
So it can't be 325 or 246.
Mm-hmm.
It obviously isn't 125 because at the bottom it has a 100 feet distance.
Mm-hmm.
So if it was 125, it would be way shorter. So the best answer would be 202 feet.
Okay,
I was
so
gonna say the exact same thing.
so this is what we think it's probably going to be. Now let's show how we get that mathematically. I know 3 sides. Well, I know 2 out of the 3 sides. What is our favorite formula that we can always use to find the third side?
Multiplication. X plus Y equals 6.
No, it's not that. What's that
Wait,
theorem?
what's pi again? What does pi equal again?
3.1415926.
3.1415 stuff. I don't know.
And if you still don't get the answer, how? I just said it.
What's the theorem, Daniel? He just gave you a clue. Jalen, you want to tell us?
Pythagorean.
Pythagorean theorem.
Mm-hmm. That, yes, exactly. Okay, so a squared plus b squared equals c squared. Fill in the blanks for me, Daniel. What do I put in each of those places?
I don't know.
Which one's the... No, you go ahead. Which one's the only one that has to go in a specific place? This goes for anyone.
And it's the largest length there.
Go ahead and explain it, Jalen. Everybody listen to Jalen because he knows.
The hypotenuse will be c squared So
The
that'll
hy-
be 2.25. Wait, 2.25. What? Hold up.
225.
225. And then the adjacent angle, well, doesn't necessarily have a place to be.
No, they don't. The
Okay.
other two don't matter. So A can be whichever of the other two remaining sides you have. So it doesn't really matter. The only one that matters is that C squared has to be the hypotenuse. Daniel, you understand?
Mm.
Okay. So X doesn't matter where it goes. 100 doesn't really matter where it goes, but C squared has to be 225 squared. Well, now I'm solving for X squared, so let's go ahead and get all these numbers. What's 100 squared?
I'm gonna guess it's 1,000.
Hmm,
Probably not.
not quite. It's a bit more than that.
I did the exponent. No, I don't want that. No, I don't want square root. Where is it? Wait, oh, that's 10,000.
10,000. Okay. 225 squared.
$50,625.
Good. What do I do to both sides?
Subtract.
Subtract. Subtract 10,000. Okay. So x squared equals 40,625. Rios, what do I do to both sides on this last step? If I'm
Looking
trying
a
to
little
get
square.
I
Wait,
need-
hold on. Yeah, I'm here.
Okay.
The last, what do you do here?
Mm-hmm.
This is squared, so I guess you like have to square root.
Good, you got it. Square root. Square root of both sides gives me my answer. So what is the square root of 40,625?
Wait, you said what's the square root?
Mm-hmm.
201.556.
Good. So Daniel, congrats. Your logic worked and you were correct.
Ha ha he he. Why I am.
But Daniel, you have to be very careful because at the end of the day, in this problem, it was a little more obvious. But if you have answer choices that are not that obvious, you still have to know how to do the math to figure out the correct answer. So do you understand Pythagorean theorem?
A plus B with A to B to C to E.
Yeah? Okay. And C is always what?
Slope.
Nope.
Slope.
Which of those three numbers always goes in for C?
The angle thing. I don't know.
Jalen, can you remind us? The hypotenuse. Yeah. Always the hypotenuse. Okay, so when you're using the Pythagorean theorem, the hypotenuse goes in for C. A and B are just whichever of the legs you want to put in. Doesn't matter. Questions on the Pythagorean theorem? Okay. Now, part B. Part B. Rios, go ahead and read part B for us.
What edge of angle elevation from the snake on the ground to the top of the monument?
Okay, angle of elevation. Which of these three, I'm going to label them. Here's angle A, B, and C. Which of those three angles is the angle of elevation? A, B,
Angle A.
Good, angle A. Nice. So that's what we're looking for. We're looking for angle A. So it's a triangle, right? So I'm just going to redraw it over here. We're looking for A. And we know a few things. We know this is 100, we know this is 202, and this is 225. So does it matter which ratio I use? Or am I pretty much able to use whichever one I want?
Aren't you supposed to be using theta or what's the other one?
Oh yeah, I can label this as theta, yeah.
Something.
But what do you guys think? Do I have to use sine, or do I have to use cosine, or do I have to use tangent, or does it not really matter which one I use?
To me, what it seemed like really doesn't matter, or
Good. Yeah.
for some reason.
Yeah, it doesn't matter because I have all three sides. I have all three sides. So since I know all three of those measurements, it doesn't matter. You can use sine, you can use cosine, or you can use tangent. It doesn't really matter. So let's go ahead and pick one. Daniel, do you want to use sine, cosine, or tangent? Up to you.
So don't know the angles, but we know the opposites, the adjacent, and the hypotenuse.
Mhm.
But I think it would be easier if we use the adjacent and the hypotenuse.
Okay, adjacent and hypotenuse. So what's that going to be? Sine, cosine, or tangent?
Oh, I forgot.
Who can tell me which one is this? Adjacent over hypotenuse.
So ka.
It's cosine. That's cosine. Okay, let's use cosine. So cosine of A, or
I'm
cosine of theta.
hungry.
Cosine of theta is adjacent over hypotenuse. Eric, I don't know, I couldn't hear you before, but Eric, if you can hear me, can you tell us what would be the cosine of theta? I don't know if his laptop wasn't working before, so I don't know if it's going to work. Okay, that's fine. All right. Rios then. What would be the cosine of theta?
I don't know. Stop.
There's a lot of commotion in that house.
That's okay.
202 over 200. Right, goddamn.
It's
Okay.
the other way around.
It's okay.
202 over 225.
That would be the
The other way around.
sine.
No,
That would be the sine.
202 over 100. I guess.
That would be tangent.
The other way around.
I don't know. I forgot.
Okay, Rios.
It's the other way around.
I'm trying to remember that word, but I can't remember how to even spell it.
So,
I just said it's the other way around.
Toa. Write it down in your notebook so you don't have to think of it in your head. Write it down.
Supposedly they're putting me back.
Oh, that's my mom. Hold up.
So it's C-A-H, adjacent over hypotenuse. So try it again, Rios. What would it be? What would be adjacent over hypotenuse?
It would be 225 over 100, I think.
It's the other way around.
No, the way around. Okay, then.
Upside down. 100 over 225. Adjacent over hypotenuse. The hypotenuse is the longest side. The longest side is this one right here. That goes in the denominator. Adjacent over hypotenuse. We got to get these down, Rios. At this point, I need you to really memorize this, because if we keep forgetting, that's the easy part. This should be the easy part. The hard part is solving for theta. Now, how do I solve for theta? What do I have to do to both sides?
Only like the inverse cosine, or
Yes, good. You got it.
I'm surprised I remember that.
I'm glad you did. That's very good.
I have
So-
horrible memory.
Well, that's why we keep practicing. The more you practice, the easier it is to remember. So we do the inverse cosine. My cosines cancel. I'm left with theta equals the inverse cosine of 100 over 225. Go ahead and plug this into your calculator. I need an answer from everybody. So Daniel, Rios, Jalen, Eric, and Samaj, if y'all can hear me, go ahead, plug it into your calculator and see what you get.
That was easy and fast. Who's that behind you, Daniel? Oh, yes, he walked away.
Hey, turn the camera on.
No.
Yeah, come on, do yours.
That's not Mr. Barry.
Okay, Daniel, I need an answer from you. Rios, I need an answer from you, please. Let's go. Answer the poll. Daniel, have you answered it yet? Let's go.
Yeah.
Okay. Thank you. See, now I know that y'all didn't even try this one. I know for a fact that you did not put this into your calculator. Only Jalen did. Because I cannot have you guessing. This is not a guessing game. We're not figuring it out in our heads. If you don't use your calculator, you're not going to know the answer. So I asked before and nobody said anything. Daniel and Rios, do y'all know how to do this in your calculators? Yes or no? Be honest.
Yes, I do.
Then why didn't you get the right answer?
I can answer it.
Do you want me to show it one more time? Yes or no?
I have to go scientific calculator.
Daniel, I'm gonna need you to sit up straight and wake yourself up because this is not good. Y'all are taking a test in less than a week and you can't even get like the most basic stuff. That's a big problem. The only one here that I know can handle things right now is Jalen. And Eric was doing really well as well, but I don't know what happened to him. Calculator out, calculator in front of you right now. For both Rios and Daniel, you're doing the inverse cosine of 100 divided by 225. Let's go. Type it in your calculator, 100.
I was sleepy and hungry and it's freezing cold here.
That's a bunch of excuses. I don't want to hear it. I do not want to hear it. And if I hear it again, I'm calling St. Rose and he's going to come up there and deal with you, Daniel, because I'm not going to deal with it right now. 100 divided by 225 gives me this. I used my second button and we're finding the inverse what?
C.
Inverse cosine. So I get 63.6. Answer choice C. Now I'm going to ask it, and I better hear the right response. Do you have any questions?
No.
This goes for everybody.
I think the calculator on the stuff.
How did I do what, Rios? Do you want me to show it one more time on my calculator? If you're not getting that same answer, I need you to make sure you know how to do it. So if you're not getting 63.6, I need to make sure that you know how to do it on your calculator. So does anybody, this is the last chance, does anybody need me to show it one more time? Okay. I'm going to call everybody else back, and then we'll go over a few more problems, and that'll be it. All right, everybody. Hi, welcome back. We're going to go ahead and go over the problems, and then Emily, Perla, and Janelle, as you guys tell me which ones were the most challenging or like which ones you want to check, and we'll focus on those. Okay. All right, so we did number 12. So this was number 12, was those three. Any questions on this one? No? Okay. Number 14, got 10.4 and then 6.7. Any questions on that one? Perla, Janelle's, all good? Okay. 15, 202 feet was the height, and then 63.6 was the angle. Questions on that one? Okay, Janelle's, you're a little confused. On which one, part A or part B? Both. Okay. So for part A, we knew, for part A, we only knew this. We only knew the two measurements of the bottom and then the hypotenuse. So Jalen, can you remind us, what did we do in part A?
What's the name? I already forgot it. Pythagorean theorem.
Yeah. So this is a classic Pythagorean theorem, because if you know two side lengths, you can always use the Pythagorean theorem. A squared plus b squared equals c squared. So we just did, we called this x, and we did x squared plus 100 squared equals 225 squared. And when you solve for x, you can get 202. Do you need me to show all the steps? No? Okay. Cool. And then for part B, since we figured out the answer in part A, we figured out that this was 202. Then it asked us for the angle of elevation. So this is just, remember, the angle of elevation is from the ground up. So this is my angle of elevation right here. And then for that one, since I knew all three sides, basically you can use the sine, the cosine, or the tangent. You can use whichever one you want. Yes. What, it's all good? Oh, they were making an announcement. Okay. So any questions, any remaining questions on this one? Oh, Jalen, nice. How will you be able to do it if you're not there?
Do what?
You got chosen for 5,000 role
Because
models.
he's not here, so
Wow.
Oh, okay.
yeah, Jalen.
That's gotta be.
Being mean to me.
How? Well, I'm just playing around. Just playing
Okay.
around.
All right, so which ones would you like me to go over? Which slide number?
The classroom one. That one, 17. Oh, look at this
17?
audio quality.
Yeah, this one was challenging. I'm glad you brought this one up. I like this one though. It's kind of the trick. Once you see the trick to it, you're gonna be like, oh, okay. 12 students are lined up to have a class picture taken. The photographer's camera has a picture angle of 52 degrees. The picture angle limits the width of the photo that can be taken. The line of students is approximately 26 feet long. About how far must the photographer be from the line of students in order to center all 12 students into the picture? So we're looking for this, how far must he be from the line of students? So if I'm trying to figure out how far away he's got to be, I'm looking for this length right here.
Oh, I
Right?
thought we were looking for one of the sides.
Nope.
That's crazy, isn't it?
Bruh.
So once you figure that out, guess what? What type of triangle does this split into?
Oh, right.
We have
Triangle.
a right triangle over here, right? So we know a few things about this right triangle because what I just did was I made the perpendicular bisector. So the perpendicular bisector means how long is this portion in purple?
13.
Yeah, that's 13. And then how much is this angle? Right here, hold on. Right here.
26.
26. So it splits the angle in half and it splits the line segment in half. So now that I have this triangle, I'll draw it over here. This is 13 and that's 26. I can figure out x. Which ratio should I use? Good. So tangent of 26 is 13 over x. And anybody who was with me just now, what's the little trick I can do here? Because I need,
Switch 'em.
yeah, I can switch the x and the tangent of 26. Just do a little switcheroo. Oops. So to get the value of x, we just do 13 divided by the tangent of 26. So let me see what I get. 13 divided by the tangent of 26. I got 26.6. So 27. Okay. So does that clear things up? I know this one was kind of, you had to realize that. Once you realize that, you're good. All right, what else? What else can I go over? The last one? Yeah, that one was another. I put this one in because I knew this would be a challenge. I wanted to really, it's not going to be this hard on the test, but I wanted to show you a good challenge question because they're interesting. So 2 boats are traveling towards a lighthouse that is 200 feet above sea level at its top. When the 2 boats and the lighthouse are collinear, the boats are exactly 250 feet apart, and the closest to the lighthouse has an angle of elevation to the top of the lighthouse of 15 degrees. What is the value of x rounded to the nearest hundredth? So basically, you can't solve for x until you find something else. First, you have to find this measurement. Because once you have that measurement, you'll know how long the whole thing is. And then once you know how long the whole thing is, you can find the angle measurement. So first, if I'm trying to find, let's call this y, what do I do to find y? Good, the tangent of 15 would be what? 200 over y. Good. And again, I can use my little trick here. What can I do? What can I switch? Yeah. I can switch the y with the tangent of 15. Okay. So 200 divided by the tangent of 15. What do we get? Good, 746.4. So now, if this is 746.4, I can figure out, now I can look at the larger triangle. And let me draw it out here. Where this is 200, this is my x, and now the whole thing, the whole bottom, I just add 250, and this whole thing is 996.4. So now what do I do to find x? The tangent of x, good. So now I do the tangent of x is equal to 200 over 996.4, and what do I do to both sides? The inverse tangent. Good. So in your calculator, the inverse tangent of 200 divided by 996.4, yeah, you should get about 11.35. To the nearest hundredth, perfect. So yeah, this one was a little bit challenging because in order to get x, you definitely had to figure out that length first. Any remaining questions on this one? Cool, I'll do 21 as well. Okay, so this one, right? All right, so it says this is RST, and then it says JKL equals RST with a factor of 1.5. What is the tangent of L? So it's telling me that there's another triangle, which is JKL. JKL is the same thing as, it's similar with a scale factor of 1.5. So JKL would be like slightly larger, right? But I'm just going to draw it next to it. So J would be up here, K would be here, and L would be here. And it's asking me what is the tangent of L? Well, there's a hard way to do this and an easy way to do this. Because, okay, we know that the scale factor is 1.5. So what you could do is you can go to each of these and multiply it by 1.5 to figure out the other triangle. So 5 times 1.5 is 7.5. 8 times 1.5 would be 12. And then the square root of 89, what is it? What's the square root of 89? 9.43 approximately. It's a little more than 9, right? So you can multiply that by 1.5. Okay, so we get like 14.15. Then it's asking you what is the tangent of L. So the tangent of L would be 7.5 divided by 12. Right? You got an answer. What do we got? 7.5 divided by 12 is 0.625. Or I don't know if, yeah, they would, it doesn't look like you can keep it as a fraction, so you would put it as a decimal. So that's the answer. That was the long way to do it. That was the long way to do it because Perla, what did you do?
I didn't think about, oh gosh, the audio. Okay, there, it got fixed. I didn't like even do the scale factor. I just took the tangent of t,
Good.
and then that's how I got my answer.
You're right. Because t is this t, angle t is congruent to angle L, right? They're the same. They're the same because you have a similar triangle. So what that means is the tangent of t has to be equal to the tangent of L. So you didn't even have to go through all that work because you end up with the same answer. Because the tangent of t is 5/8, which gives you the same exact answer, 0.625. So that was kind of like the trick. You didn't have to go through all that. You could have just done it the quick way. Make sense? Cool. Okay, we have time for maybe one more. Anything else? Any of the others? 18, 19, 20, or 16? Feel good about those? Cool. So yeah, I can tell you the answer. I don't have it off the top of my head, so I don't have them written down, so I'll have to do them really quickly. Okay, but for this one, this is the angle of what? What is this called? Angle of?
The angle of sadness.
Yeah, the angle of depression. And the angle of depression is equivalent to which other angle?
Angle of big sad.
No, it's the angle of happiness.
So, right, so these are going to be equal. So x is equal to this one down here. Those are both going to be the same because you have parallel lines. So what are they to each other? What are those two angles to one another?
Opposite interior. I'm not sure.
Yes, alternate interior.
Oh,
Alternate
an
interior.
alternate.
Yep, they're alternate interior angles, so they're congruent. They're the same. So now that I know that, I can set this up. Okay, so that would be the tangent of x is 125/500. So we take the inverse tangent of 25/500. So let me see what I get. Uh, 25/500, right? 25/500. Inverse tangent. Inverse tangent, what do you, oh, 125. That's what I was doing wrong. There we go. Yeah. What do you get? I got something different. Oh, never mind. I got the same thing. 14 degrees. Sorry. I don't know why I feel like I kept plugging in the wrong number. So this one's 14 degrees. Questions on this one? Or you guys got it? You got it. Okay. Cool. Okay, this one, you had to kind of draw it out. But here's my ladder. Okay, so he places it an 18-foot ladder. So this is 18, 6 feet from the house. Find to the nearest degree the angle at the bottom. So we're looking for theta. You did the same drawing, good. So here we would use cosine of theta equals 6/18. So the inverse cosine of 6/18, 6/18 inverse cosine, 6/18 inverse cosine, we got 70.5. Is that what you got? Good. Cool. Next one. I have 2 minutes. How fast can I do this? Okay. A student stands 50 feet away from the front of a building. So Here's the building. Here's my person, 50 feet away. The angle of elevation from the top of the building from the student's eye. So from his eyes, the student is 5 feet from the ground and the
Square.
angle is 30. And we're trying to figure out the height of the building. So I know that this is 50. I'm going to look for x. So tangent of x, or tangent of 30, sorry, equals x over 50. So 50 times the tangent of 30 is x, and then we're going to have to add 5 feet to that. So tangent 28.8 is what you got. Tangent of 30 times 50. Yeah, you got 28.8, but what do you have to do to that?
At the height of Miss Lopez.
At the height of this human who's not named Miss Lopez. Technically, it's 28.9. So 28.9 plus 5. Ooh, I got students coming in already. We got 33.8. So it's D, 34. All right, y'all. So that is all. That is our big review for trig functions. Tomorrow we're going to be reviewing similarity. On Friday we'll be reviewing similarity in triangles. And then on Monday we'll do one kind of big review of everything, and then you test on Tuesday. So have a nice night, everybody. Make sure that you study, make sure you review, and I'll see you all tomorrow. Bye,
Bye-bye.
Eric. Bye, guys.